So it's good that there are multiple ways to control the output of an LLM. I think, the developers of multiple LLMs want people to control it more because end of the day, there is a certain black box inside it where even the person who has trained it, right, will not know exactly what output it's giving.
Sometimes when you're implementing a solution on Gen AI, people will get confused whether should I use prompt engineering itself. For example, let's say there's something that we were trying to build, which is like a coach or a personal assistant as a Gen AI, where I can say, hey, you are a personal assistant now for the CEO, and I, give it some commands and it gives me some response. Whereas, what is the difference when I say I want to make a fine-tuned model which is a personal assistant for a CEO? So, what are these two different things? One is you have the prompt engineering where you're telling that, hey, now you act as a personal assistant, and then I give multiple questions to it and it answers. Whereas fine-tuning a model, which is like I'm telling you are now a personal assistant, but I fine-tune it on what kind of data that I have and how do I respond back. So what are these two differences, and if you can throw some light on
So
that?
there are actually three ways you can actually control the output of an LLM. One is prompt engineering. Then there's a method called RAG, which is Retrieval-Augmented Generation. And the third is fine-tuning, of course. So the best part is, so it's good that there are multiple ways to control the output of an LLM. I think, the developers of multiple LLMs want people to control it more because end of the day, there is a certain black box inside it where even the person who has trained it, right, will not know exactly what output it's giving, right? So if on in a business use case, on a business level, if you're not able to dictate what an LLM should do, then it's not of much use to you, right? So that's where these three methods really become really handy. So these three methods are all useful in their own ways, but I'm going to start by the least sensitive to the most sensitive method. And when I mean sensitive, I'll get to why I'm using the word sensitive. So when you say you want to fine-tune a model, so fine-tune is purely behavioral change. So if you want your LLM to output in a certain way or to look at certain things in a different way, that's when you fine-tune. So you're talking about a coach, right? So if you want to control the tone of a coach, right, and you wanted to mimic an actual coach, maybe a career coach or a lifestyle coach, right? Or any kind of coach, right? So coaches use certain words. They have there's a certain sequence of words they use. They analyze things in a different way, right? So they will ask for the right type of information in steps, right? Versus if you have some other profession, maybe they will ask for all of it at once, right? So this is just an example of why fine-tuning can change the behavior. So the behavior of an LLM will be changed by fine-tuning. If you have, let's say you have 20 examples of an interaction. So it's called prompt completion pairs, right? So prompt completion pairs is you ask a question, you get an answer, and you have 10 of these pairs, and you use these pairs to fine-tune a model. So what your LLM will do is it will reassign all of the weights that we talked about to make sure that it's more like these 10 examples. So its tone will be like the 10 examples. It will look at a problem like the 10 examples if you give it a format. So essentially GitHub Copilot, right? If you ask it to generate code, it is basically been fine-tuned on top of GPT to generate code, right?
Right.
So that's an example. So instead of giving out text, you will give out code. So fine-tuning should only be used for changing the behavior or the output of an LLM. So if you want to control things like tone, the way image is, the way data or content is processed, stuff like that. right? Uh, there is a drawback though. The drawback is that fine tuning is, I wouldn't say permanent, but it's once you fine tune a model, it cannot take dynamic data. So every time you have new data that you want to fine tune, you have to retrain the model.
It trains it.